Sanibonani, igama ngiko, and I'm your mathematics and physical sciences tutor. As we continue on this section, Newton's laws, right? So I want us to quickly focus on the coefficient of friction. Ane? Okay, so please follow along and listen very carefully. So they say the coefficient of friction depends on the material of the two surfaces that are in contact, right? Now, I want us to look at these two examples over here so that we can know the difference, right? Okay. Tire on a wet road or shiny tile has a low coefficient of friction. That means it slides easily on that surface, right? And the tire on a gravel road has a higher coefficient of friction. This means that it has more grip and it slides less, or there is less sliding. If we were to think about it in a sense of relativity, it means that our frictional force would then be directly proportional to a coefficient of friction, because the higher the coefficient of friction, the higher the frictional force being experienced, right? And the lower the frictional force experience means that the lower the coefficient as well as the frictional force being experienced, right? Okay, now if we continue reading and moving along, I hope you can see that clearly. I am sorry if my handwriting is, no, I'm sorry. But yeah, if an object is at rest, then there is a static frictional force, you know? Um, and we see this by EFS max and this arrow over here. Remember what I said about this arrow? It represents a vector quantity. Ano? Okay, as we continue, they say if the object is moving now, then there is a kinetic frictional force shown by this Fk and this arrow over here, which also shows us that that frictional force is a vector quantity. Okay, now to make sense of these two statements, it means that when an object is stationary and at rest, it is not moving, there is static frictional force. But if this object is now moving, whether it is moving slow or fast, it is moving, then we know that there is kinetic frictional force. Now, I want you to think back in terms of kinetic energy. Kinetic energy refers to electrons and the energy required for something to move, whether it is an object or electrons, you name it, right? Kinetic, anything and everything that has to do with movement. Okay. Now, in order for an object to start moving, it has to reach and exceed the maximum static friction value, right? Okay, before I give you this example, I want you to look back into our previous lesson when we were speaking on the correlation between static friction as well as kinetic friction. And we read that when a small force is applied on an object at rest, the force of friction increases as the applied force increases. And we note that this continues until static friction reaches a maximum value. It cannot increase further. Eventually, maximum static friction force is reached or exceeded, and the object starts to move. Okay, let's go back to this example over here, written in red. Because I want to highlight this example. Ane? Now, let's think of the photoelectric effect. If you have not done that topic, or you have not read about the photoelectric effect, the section on physics, then worry not, we will do that topic eventually. But if you have, kudos to you. This is just a reminder. Okay. Now, I want us to think of equilibrium or threshold value when we speak on exceeding the maximum static frictional value. Okay, now with equilibrium comes in with chemistry, more specifically the topic of chemical equilibrium. And then a threshold value comes in place when we speak on the photoelectric effect, more especially threshold frequency, you name it, right? Okay, now when light is shown on a metal surface, electrons may move due to heat or intensity, but will only be ejected from the metal surface once the threshold frequency is reached. Once the threshold frequency is reached, those electrons would have gained kinetic energy. Coming back to this word, kinetic. Kinetic is all about movement. Please do not forget that. Okay, as we move along, Anna? Now, continuing on the conversation and the example about equilibrium and threshold value. Anna? Now, kinetic frictional force is therefore introduced as the maximum static frictional force is reached and exceeded, but decreases to a relatively smaller value than static frictional force. Okay, now let's think about it this way and actually debate about this. So, the above mentioned statement suggests that a kinetic frictional force is introduced when we reach a maximum, ane? A maximum value of static frictional force. This is when we reach equilibrium or a threshold value. You know, once we reach that maximum height or maximum value or maximum threshold, maximum or equilibrium, and we start to see now that the reaction is no longer taking place, right? That's where a chemical equilibrium comes in with that concept of dynamic equilibrium, right? Okay, now let's not go way further than where we want to go with this particular topic. Now, let's not stray, Anna. So, we know that, okay, once our static friction reaches its maximum value, it will now drop down into the smallest or minimum value of a kinetic friction, which in this case will then need to start working its way up, right? Look at this now. Maximum static friction is bigger than kinetic friction. The maximum static friction is bigger than kinetic friction. Anna? If we were to make sense out of this, Anna, as well as this slope inyana over here, let's take the sign as a slope, Anna. The maximum static frictional force at its maximum, and if that point is reached and exceeded, we now introduce kinetic friction, and it needs to start from the bottom and work its way to the top. And as it does that, it's explained that the friction then decreases to a smaller value and called a kinetic friction. We already know that, né? But the kinetic friction remains constant while the object moves at a constant speed. Remember the example I used about pushing a car in order to kickstart it. That car, once it starts moving, and it will move at a constant speed unless the people pushing that car start to run to change the velocity with which that car is moving so that it can gain a momentum as well as increase um, or override the kinetic friction, causing it to either slow down or move at a constant speed. And yeah, let's not go into the nitty gritties. We will get to the topic as we keep on going, as we've been doing. All right, now we must remember that our coefficient of friction is directly proportional to the frictional force or the maximum static friction or the kinetic friction. Do not forget that. Okay, okay. Now, sorry about that. We have two portions that I want us to look at. Anna. And firstly, I want us to focus on the left side of this paper before we get to the right side of this paper. Now, the left side of this paper, we focus on horizontal surfaces. Anna. And in this example, we are given a car, and if I may assume, it is moving towards the east, which is your right side. It is moving to the right or eastward, and it experiences a frictional force due to the surface or this rough surface, right? And we see that a kinetic friction in this particular case, because this car is moving, is due to the opposite direction, and in this particular case, it is towards the west or the left side. Yeah. Okay. Now, I want us to remember when we spoke on the normal force as well as the force of gravity or the gravitational force, we know that those two they balance each other out, but they are moving in the opposite direction with regards to each other. And so if we were to take the north or upward direction as positive, then our force of gravity would then be negative. Now, a force of gravity, we know that it is made up of a mass as well as the gravitational acceleration. Mass as well as gravitational acceleration, just to remind you if you may have forgotten that piece or that bit. And since we know that force of gravity is made up of a mass as well as gravitational acceleration, then it means our normal force in this case would then equate to the opposite, right? This negative sign of E force of gravity, right? This sign means that it is moving in the opposite direction, right? Of our mg. Okay. And because our normal force is always acting perpendicular to the surface, it is always vertically upwards. It forms a 90 degrees with that surface. And our frictional force in this case, we would know that it is equal to the coefficient of kinetic friction in this case because the object or the car is moving. And it is equal to this coefficient of kinetic friction multiplied by the normal force. But in this case, we know that a normal force here too is the opposite, which is E gravitational force. And we know that E gravitational force is moving in the opposite direction towards the normal force. In this case, it is always vertically downwards. By taking upwards as positive, the downward motion would now be in the negative, right? Now we would have our normal force being equal to the negative or the opposite of, or in this case, the gravitational force, but in the opposite. This negative comes in, would therefore come in here. And then, now I'm just going to highlight it in red. Please don't mistake this negative as a minus. I put a bracket in there to show you that you are still multiplying these two. And so our kinetic friction in this case would be calculated using the coefficient of frictional force, in this case the kinetic friction, multiplied by the negative value of our gravitational force, similar to our normal force. Okay, now if we were to move to the right side of our paper, or right side of the screen, whatever you may prefer. Okay, now looking at inclined surfaces, we see that in this diagram, we are given that this car is moving at an inclined surface. I don't know if you know, a steep hill, when a car is moving in that steeper hill, inokudonsa kanzima. Some trucks you may hear sounds like "Vrrr," it is because that car or that truck is moving at an incline. More energy is needed to overcome the friction, causing it to move downwards. Now, that friction is not only working alone, and it would then be working with a gravitational force pulling it down. Yeah, but since we have an inclined surfaces, we know that components are to be used. Components, which is your horizontal components as well as your vertical components. And in this case, we must remember that a gravitational force that is parallel, that is moving in the same plane as our surface. Our surface would be, sorry about that, our surface in this case would be this red pen, but our gravitational force would then be moving downward, but in parallel to this surface. And we know that that equation or that calculation would be force of gravity multiplied by the sine theta. The sine theta is this angle over here, the angle of E elevation. And we know that E force of gravity is the same as mass multiplied by gravitational acceleration, and in this case, multiplied by the angle of theta. And now, the force of gravity perpendicular, right? Moving downward, and because the force of gravity is always moving downward, whether parallel it is moving or sliding downward, whether perpendicular it is still going to be downward, and in this case it is in the opposite direction of our normal force. The red pen would represent our normal force because it is always acting vertically upwards. Yeah, well, it is the force exerted by our surface in this case. And now we know that a force of gravity perpendicular is the same as saying force of gravity multiplied by the cos of E theta. Okay, there is another lesson on the components, but I just want you to make sense out of this. Remember that this theta, there is an angle causing this to be a right angle. And I hope you can see that, causing this to be a right angle. Remember, that this is the opposite of our angle, and this is our hypotenuse because it is opposite to the 90 degrees. Therefore, this would be our adjacent, but we're not gonna regard anything within this adjacent part. We're just gonna focus on these two because they are both opposite the angles that we are mostly interested in, right? Now, the hypotenuse is always opposite the 90 degrees. The opposite side is always opposite or is always in relation to the angle we are interested in, right? So sine equals to opposite over hypotenuse, opposite over hypotenuse, right? Okay, now the cos now in this case, the cos would be the adjacent part of it. Remember, our force of gravity is always vertically downwards, but it is now perpendicular to the normal force, and therefore we would be interested in this would form a 90 degrees. Okay, let's do this. Okay, this would be our normal force. Going down would be our force of gravity, right? Now, in this part over here, please watch my next video. It's going to be explaining everything in detail with regards to our inclined planes, which is your components in the horizontal as well as the vertical. Okay, now, but we know that, and we know that our frictional force or our kinetic frictional force is equal to the coefficient of kinetic friction multiplied by a normal force. And remember, our normal force is usually force of gravity or the mass multiplied by gravitational acceleration. But in this case, we don't have a force of gravity, but we have the perpendicular version of a force of gravity. Now, because our normal force is equal to the force of gravity perpendicular, then it means that the formula we will use in calculating our kinetic friction would be equal to the coefficient of kinetic friction multiplied by the force of gravity perpendicular, right? Now, we know that the force of gravity is the same as saying mass multiplied by gravitational acceleration, but because it is in the perpendicular, we're going to use the cos, sine, and theta of this angle theta, right, to actually find our frictional kinetic force. Ooh, that was a mouthful. Yeah, I'm a bit drained, but yeah, please don't go anywhere. We're going to be doing components as well as inclined planes in particular. So yeah, please don't forget to like, comment, share, and subscribe. If you still don't understand anything on what we discussed on this episode, please comment down below or send us a direct message on Facebook. Let's interact and talk with each other. All right? From me to you, Dango.